So we're going to use the MySQL sample database script for our examples for create table. We'll write some of our own too, but we're going to start here with MySQL sample. As we know, that creates a classic models database. It shows some good things in here, and a couple of things I disagree with. One thing I disagree with is the use of backticks here. Backticks allow bad practices because they allow spaces to be put into identifiers, dollar signs, any symbol can be put into a name here. Now, many automated tools can hook to MySQL. That's one of the great features that SQL, I think, may have even pioneered. It's self-describing. So we can see this use in the MySQL workbench. So when MySQL wakes up, it asks the SQL server, what database schemas does this user have access to in order to populate the tree that we see on the left? And then when it gets the schemas, what's the name of the schema and what tables does it support? So all of those are queries that the MySQL workbench had to exercise against SQL to say, what's your data structure? Well, that's very nice. There's a lot of automated tools that can essentially write code for you for basic reads and writes to SQL based on the database definitions. So you're asking for trouble if you use exotic identifiers that will solidly will not work in other programming languages such as Java. So avoid the use of backticks in human created scripts. You'll see them in automated created scripts, that's fine, but for human created scripts, backticks probably not good. So let's look at create table and a few of the column definitions here. So we have the column name here and then the data type. So let's look at our data, the MySQL data types. The first thing we notice here is it says integer. So when integer, MySQL will allow you to either use the shorthand int or spell it out integer. It makes no difference there. It's not a different data type as it is in Java with the data wrapper versus the primitive type. Integer and int are essentially synonyms. So that's a direct mapping to our Java type. Integer maps to int. Now, one thing that's different here is this 11 here. And I think this is a little bit misleading. Let's discuss the varchar here, which is our string in Java, varchar string. That has in SQL something different than we express in Java, and this limits the length of our string. So it's a variable length string that is variable length storage requirements. It only takes the storage that the string actually requires. So if there's 0 or one character there, it doesn't take up a spot for 50 characters. And varchar is what's normally used in production databases for string. I've never really seen the use of any other thing in a production database. So this means 50. It means that, right? So it's natural to interpret this parenthesis 11 as meaning something about the underlying storage of the integer, and it's not. It's 11 is the default character length of the display when the SQL select statement runs. So I think it's best not to specify that. It's confusing. I wouldn't specify the parenthesis 11 there. So not null. That's our constraint. So that has to be there, and in fact, most of these columns we can see are not null up until we get to address line 2, which defaults to null. That is, it allows a null. Null is the default case, by the way, so if you don't have any kind of column constraint at all, remember, constraint is a rule on the column. If it's not there, then that column allows nulls. Here, this keyword default means the default setting for the variable if it's not specified on the insert. So all of these can have default statements as well. So you could default the customer name or the contact last name if there's meaningful defaults. In most cases, there aren't really here. It'd probably be a mistake unless everyone's named Fred to have a default name. You're likely looking for a mistake. So the other thing I want to say about here is similar remarks about this. This is not display, or this actually has some meaning in terms of how the data is dealt with by SQL. This is the precision in the mantissa, that is 10 digits of precision in 2 decimal places. I would avoid using that as well. In fact, I think that's deprecated now. Make your data types map as closely as possible to the Java data types, and since Java doesn't allow this is big decimal, we don't specify mantissa or precision in that. That's deprecated. Don't use it. We want to lower the friction of translation between data between Java and SQL as much as possible. So the next constraint here is not a column level constraint, it's a table level constraint, and that's the definition of the primary key. Remember that primary key is the f of x that the mathematician would think of, right? X being the primary key, and the function produces the data row that the primary key resolves to. So customer number has to be unique across the entire table. So if I have customer number 10 and I insert customer number 10, objection. That entire row would be rejected, fix up the primary key, and try to reinsert it. It also creates an index, but that's as a secondary effect. About its main thing is being about the structure of the table. Almost all tables, I'm going to say all tables in a production database should have a primary key defined for them. A lot of tools, a lot of automated tools that attach themselves to databases and do work for you will not work on a table that doesn't have a primary key. Here's the creation of a normary key. Key is a synonym for index. The keyword index could also be used here. And that creates a fast lookup. So it doesn't say anything about the underlying logical structure of the database. It's what you're expressing, say, your user interface. Let's say maybe it's used by a customer support representative. When a customer calls in, how do they want to look up that customer? In the design here, this is indicating to me that their user interface asks for the sales rep in order to produce a list of customers that person represents. Some other logical targets for an index or a key created on them would be last name and first name, maybe phone number. Anything that you think of in the user interface that's going to be used to look up the rest of the data should be indexed. If it's not indexed, again, like for example, if we searched on postal code, it's not indexed, and we had that in our user interface, it would have to scan the entire table from beginning to end in order to find postal codes that match the search criteria. The next constraint we see is actually a constraint that works across different tables, and that's the foreign key constraint. Very important. Again, foreign keys are what put relational in relational database. From the name, you should understand how important they are. It's called explicitly a constraint. All of these things, by the way, are constraint. Primary key is a kind of constraint. Key doesn't really have a constraint in terms of restricting your data any, but I think you can still loosely put it in the constraint category. This is definitely a constraint. So let's take a look at the syntax of this. So the first thing we see is the name of this foreign key, and I know this is imposing a naming convention, and a naming convention that I don't think is that strong. I think the naming convention should be something like customers underscore foreign key. I like that, but IB, I don't know what that means. And then underscore when that indicates, I think, the count of foreign keys in this table. Well, instead of that, I would put the table name it's a constraint on. So customers is a foreign key to another table, and we'll see that later in the syntax what it's a foreign key to, but that should be part of the name. So constraint, the name of the constraint, then the keyword's foreign key, and then the index where the foreign key is defined on. That is, this column is going to foreign key to another table. So think of it as a fishing line that's being strung out from sales representative employee number to this other table, right? And not just that table, but employee number within that table. And we've used this in queries to tie together queries to say, give me a list of customers and their sales representative. That's where that line comes up in the enterprise relationship diagram that we've reviewed. And that's what we use in our join conditions to find those related records. So on the join conditions, you can join any column to any column. So don't think this foreign key is the only thing you can join on. It's just the most likely thing that this database designer has thought of as relating this one table to another table. Now, why is it called a constraint? Why is it a rule? So once I have a customer here that's defined, I have a customer and I've defined an employee number. I can't fire that employee, not directly, right? I can't delete, let's say fire an employee and just delete the employee record because this constraint exists. That's a data constraint. So customers that refer to that employee as their sales representative will have to be modified to a new employee and relate to a new employee before that employee record is modified or deleted. That's a data constraint across tables. This customer record is not complete, is not valid. Its referential integrity has been violated if the employee's record it relates to is modified in a way that breaks this relationship. You can change the name of the employee number. You can change the office where the employee number or where that employee resides. But you cannot change the employee number if there's a row in the customers table that refers to it. That's a foreign key constraint. And that's the relation in relational database. It's an ironclad guarantee across tables. Now the create table statement here is followed up by the engine InnoDB. This is a characteristic that I would not specify here. The engine means the underlying storage engine for MySQL. This is a unique aspect of MySQL. All SQL instances have storage engines. The storage engine is the underlying software that stores the data tables, or the data actually in the tables. So SQL is a layer on top of that against the underlying data structure. So this data engine InnoDB is defaulted in SQL. It's the default data engine. So it really shouldn't be specified by the human being. Just accept the default. Unless you want to specify a different storage engine. So storage engines in MySQL are plug-inable. You can plug in the appropriate, a different type of storage engine. That's what makes MySQL unique, by the way. So all SQL instances have storage engines, but MySQL is unique in having pluggable storage engines. And this default char set being Latin 1, this restricts our database to Western European languages for the most part that use the Latin alphabet. It's a mistake. It should use Unicode. We'll talk more about Unicode later. But this is our basic create table statement, and now we can begin to understand more, and we'll look at database insert statements, this data insert next.